Welcome back to The Explainer. So let's just dive right into it. Today, we're unpacking an absolute giant in the tech world. We're going to decode the entire Selenium Web Automation ecosystem. Look, whether you're totally exhausted from manually clicking through the exact same repetitive web tasks until your fingers literally go numb, or maybe you're an engineer looking to scale up some serious enterprise testing, well, consider this your complete blueprint. We're taking you all the way from the foundational architecture right down to executing some pretty advanced code. Here's the blueprint we'll be following today. We're going to cover the power of browser automation, decode the Selenium architecture, look at launching and navigating browsers, figure out locating and interacting with elements, master those tricky waits and actions, and finally, explore the wider Selenium ecosystem. Let's get to it.
All right, part one, the power of browser automation.
So, performing any task using a tool or a machine is basically the definition of automation. And the advantages? They're incredible. Seriously, a well-written script can execute a 10-minute manual test in literally milliseconds. These scripts are restless, they execute way faster than a human ever could, they can multitask like crazy, and their accuracy is just unmatched. Why? Because it takes the human error out of the equation. But hey, we've got to be honest about the trade-offs here. The initial investment of your time and resources, it's high. Your code is going to require constant maintenance because, let's face it, websites change all the time. Plus, it demands specialized skill sets. You've got to know Java, Python, C#, or something similar. So yeah, it's a heavy upfront lift, but for a massive, massive long-term payoff.
And that brings us to Selenium itself. It's this free, open-source giant. But the absolute crucial point you need to grasp here is that Selenium isn't just one single tool. Nope, it's actually an umbrella project. It provides the infrastructure for implementations of the W3C web driver specification. So what does that actually mean in plain English? Basically, it means you can write interchangeable code in 14 different programming languages. Think Java, Python, Ruby, you name it, and then use that code to natively emulate user interactions across all the major web browsers. Pretty cool, right?
Moving on to part two, decoding the Selenium architecture. Okay, at a high level, the flow looks something like this. When you're sitting there writing code in Java or Python, you're using what we call a client, or a language binding. Now, this binding sends API commands over to the WebDriver. But here's the kicker. The WebDriver does not talk directly to Chrome or Firefox. Instead, it communicates with these specific driver executable files. Think chromedriver.exe for Chrome or geckodriver.exe for Firefox. Those executables act as the bridge. They're the ones actually passing your commands directly into the target browser.
Let's look at a more specific example to really nail this down. I like to call this the translator analogy. How does Selenium actually perform an action? Well, it calls the native methods of the browsers themselves. Say an automation engineer writes closing in their JavaScript. The Selenium Developer API receives that command, translates it, and passes it right through that driver executable. And the browser developer, the folks who actually built Chrome or Firefox, they already have a native method, maybe something like close browser, that actually shuts the window down. So essentially, Selenium is acting as this universal translator between your specific code and the browser's native language.
Now, for those of you using Java, this right here is the exact class hierarchy you'll be working with. The supermost interface at the very top is search context, which actually contains your foundational find element methods. Then search context is inherited by the WebDriver interface, which adds 11 more methods to your toolkit. All of these interfaces are ultimately implemented by a class called Remote WebDriver. And finally, the specific browser classes like Chrome Driver or Firefox Driver, they inherit from Remote WebDriver. Honestly, it's an incredibly well-structured hierarchy. It ensures your code remains perfectly consistent no matter which browser you happen to be driving.
All right, part three, launching and navigating browsers.
Traditionally, setting up a Java project follows this exact pipeline. First, you need your Java development kit, plus an IDE like Eclipse. Then, you've got to go download the Selenium jar files and those specific driver executables we just talked about. And before you even think about launching, you'd have to use system.setProperty to tell your script exactly where, say, chromedriver.exe is hiding on your hard drive. Only after doing all that could you finally instantiate the browser. Now, quick side note here, the modern Selenium project actually recently introduced a built-in tool called Selenium Manager. It totally automates this driver download process in the background, which makes this whole setup a lot cleaner today than it used to be. So, once your browser is finally open, you actually need to go to a website, right? You've got two main options for this: get and navigate. Understanding the difference here is absolutely crucial.
Get is your safe, standard command. It enters the URL, and it intentionally halts your code execution until the page loads completely. Easy. Navigate, on the other hand, unlocks the true power of browsing history commands. It enters the URL, sure, but it does not wait for a complete page load. This is awesome because it allows your script to simulate things like clicking the back button, the forward button, or just hitting refresh on the fly.
Next up, part 4, locating and interacting with elements. In the world of Selenium, absolutely anything present on a web page, whether that's a button, a text box, an image, you name it, is called a web element. And because web pages are built using this HTML tree structure, which we know as the DOM, we have to give Selenium exact, precise directions to find these elements. We do this using things called locators. Basically, we can tell our script to go find an element by its HTML ID, by its name, or by using much more complex structural paths like XPath or CSS selectors. Locating elements accurately is super important because, as we all know, web forms can get highly complex really fast. Like, if you need to interact with a drop-down menu, you don't just click it. Instead, you use Selenium's dedicated Select class that lets you choose options using handy methods like Select by Visible Text or Select by Index. Or, if you're dealing with checkboxes where you need to select multiple values at once, you might actually need to write a quick loop that grabs a list of all those checkbox web elements and literally clicks them one by one. Okay, so once you find an element, you've got to act on it. But before you just blindly type into a box or click a button, a truly robust script is going to check the state of the page first. You can use isDisplayed to verify an element is actually visible to the user, or is enabled to make sure a text box isn't locked out. Then you've got getAttribute and getText to read data straight off the screen. And finally, when you are ready to type, you use the famous send keys method. That one inputs text or can even simulate keyboard strikes, like hitting the Enter key. It's super versatile. Moving right along to part 5, mastering weights and actions. Let me pose a question to you. What actually happens when the browser is slower than your code? Think about it. Your script runs in milliseconds, but a modern dynamic website might take 2 full seconds to load a pop-up window or render a submit button. If your code tries to click a button that simply hasn't rendered on the screen yet, it throws this dreaded error called the no such element exception, and boom, your test crashes. So we really have to synchronize the blazing speed of Selenium with the real-world speed of the application. And we handle this synchronization using weights. Now, an implicit wait is kind of like a global safety net. You set it just once, let's say for 10 seconds, and it tells the WebDriver to always wait up to 10 seconds for any find element command before giving up and throwing an exception. Pretty straightforward. But for really dynamic elements, we use explicit waits. This uses the waitWhat class to pause your script's execution for a targeted specific condition, like waiting specifically for a progress bar to disappear or for one specific button to become clickable. It is quite literally precision surgical timing for complex loading scenarios. Finally, part 6, the wider Selenium ecosystem. It's important to remember that WebDriver doesn't operate in a vacuum. It's just one part of a wider ecosystem designed for massive enterprise scaling. Look, if you have 1,000 tests, running them one by one is just going to take way too long. That's where Selenium Grid steps in. It allows you to distribute and run your tests in parallel across multiple machines, browsers, and operating systems all at the exact same time. Also, if you have team members who maybe don't know how to code just yet, they can use the Selenium IDE. It's a handy browser extension that just records users' actions and plays them back. Oh, and as we mentioned earlier, Selenium Manager is now built in to handle the massive headache of driver executables entirely automatically. Wow, okay, we've covered a massive amount of ground today. Let's do a quick recap of everything we unpacked in this blueprint. We started off by looking at the sheer power and trade-offs of automation. Then we decoded the architecture that literally translates your code into browser actions. We learned how to launch and navigate those browsers, and we mastered locating elements hidden deep in the DOM. We also figured out how to sync our code using explicit waits, and finally, we zoomed out to look at the wider Selenium ecosystem with tools like Grid and IDE. You now have the complete blueprint from top to bottom. So take a hard look at your daily workflow and all those repetitive tasks just eating up your valuable time. With this kind of power right at your fingertips, what will you automate next? Thanks for hanging out with me on this explainer, and I'll catch you in the next one.